Hi, welcome to an Arduino step-by-step course by Robojax. We are going to measure temperature, pressure, and approximate altitude and display it on the serial monitor. Then I'm going to test it with measuring approximate altitude at 25th floor to see the difference between first floor and 25th floor. And I'm going to show you how to display it on a LCD screen 1602 with 2 lines, and we are going to display it on the LCD with 4 lines. Then I'm going to demonstrate it how to control a relay where you can control a load, heater or cooler or whatever you want with this. I'm going to provide you the code so you can use 2 or more of these sensors at the same time. Wiring diagram for BMP390. And if you purchase this pink sensor of BMP390, we are reading minus 10 degrees Celsius, 13 degrees Fahrenheit. This is a BMP390 barometric pressure, temperature, and approximate altitude sensor. This is very precise with comparing to BMP180, BMP280, and other previous versions. And because of the precision, I am making this video. The actual sensor is this tiny sensor. The rest of the components are making it possible to be used with SPI and I2C, all the resistors, whatever is needed. And also there is a voltage regulator, so you can use this with 3.3 volts and 5 volts. Here I'm connecting it to 3.3 volts and it works fine. So you can connect it to 5 volts or 3.3 volts. That like this with these cables and connector, and I have no idea where to use this and where this will be used. But anyway, they also provided with this header where we can solder it either from this side, because the sensor is on the other side. I believe we should solder it in here. The sensor is also sold in this type of package, $8.80 with $4 shippings. If you connect it to external 5 volts, if this pin is 5 volts, it goes to the regulator and comes back. You can output or get 100 milliampere 3.3 volts from this pin. So this is output pin for 3.3 volts if you connect 5 volts here. The logic level, do not worry if you connect even 5 volts or 3.3 volts. There is a logic level converter which will take care of everything. So it can work with 3.3 volts logic or 5 volts logic, no worries. So you can also display temperature in Celsius, for example, if you want Fahrenheit, pressure in hectopascal, altitude, approximate altitude, based on the pressure from sea level. So we are displaying it on the LCD, either LCD 1602 or LCD 2004 in 4 lines. So this will be very easy if you followed my previous lectures. I have full explanation of this LCD and how to use it. The link for that video is below the video in the description. And here is the manufacturer website, Bosch, that's a German manufacturer, and the pressure sensor BMP390. Height of the sensor is 0.75 millimeter, the width is 2 millimeter, and length is 2 by 2 by 0.75 millimeter. These are the characteristics of the actual sensor. So the pressure that it can measure is from 300 pascal up to 1250 hectopascal. And the VDDIO, the input output, the voltages are 3.6 volts. The supply voltage is 3.3 volts here up to 3.6. But we have here a voltage regulator which will work with 5 volts. Interface can be I2C or SPI, where the current that it consumes is 3.2 microampere at 1 hertz every second. It will update the data at 1 hertz. Absolute accuracy of pressure is plus minus 0.5 hectopascal at between 0 to 65 degrees Celsius with this range. Relative accuracy of pressure plus minus 0.03 hectopascal. That's equivalent to plus minus 25 centimeter. So pressure that we are measuring, or the altitude, it will vary minimum of plus minus 25 centimeter. Long-term stability is in 12 months, it will go up plus minus 0.16 hectopascal. Maximum, that's the most important one, maximum sampling rate is 200 hertz. So in 1 second it can read the data up to 200 hertz. And here's the wiring diagram for BMP390 with Arduino Uno. The VN is connected using orange wire to 5 volts. Ground is connected using yellow wire to ground. SCL is connected using green wire to the last pin. This is SCL pin. And SDA is connected using blue wire to the second last pin. Connect SCL to the last pin in here, and SDA to the last second, or A4, via blue wire. And if you purchase this pink sensor of BMP390, VCC is connected using orange wire to 5 volts. Ground is connected with yellow wire to the ground. SCL is connected using green wire to the last pin, and SDA is connected using blue wire to the last second pin. You can also connect SCL to the last pin in here, and SDA to the last second, or A4, with the blue wire. And here is my wiring. Orange wire from this top, from this side, is connected to 5 volts of Arduino, connecting it to 3.3 volts, and it works fine. One pin is empty, the third pin is ground. I've been connected using yellow wire to ground of Arduino. And then SCL is connected using this green wire to SCL in here, and blue is SDA. It has been connected to SDA pin. SDA blue can be also connected here to A4, and SCL can be connected to A5. So you can use that for something else. These pins are exactly the same as these two pins. Here is the wiring diagram for BMP390 with LCD. We are connecting VN to pin 12. This has been defined as extra 5 volts in the code. Ground is connected using yellow wire to the ground on this side. SCL is connected to the last pin. SDA is connected to the last second. This is for the sensor. For the LCD, ground is connected using this brown wire to ground. VCC is connected to 5 volts. SDA using orange wire is connected to analog 4, or A4. SCL is connected to A5. If you're using this pink module for the LCD, it's exactly the same, but here VCC is connected to 12 volts, ground is connected to the ground, SCL is connected to the last pin, SDA is connected to the last second. I've connected the 5 volts or VCC to pin 12. I have defined it as power or VCC for this module, and yellow, the ground pin is connected to the ground, and then we have green, SCL have been connected to the last pin, and SDA is connected to the last second pin. So these are SDA and SCL. So the sensor is connected to this pin for this LCD. I'm showing you very close up so you can see it. Ground is, and here ground is connected using this brown wire to ground. The next pin is VCC. This VCC is red, have been connected to 5 volts. SDA is orange, it has been connected to A4. And last pin is SCL, it has been connected to A5. And here's the wiring if you want to use the SPI. All the pins have been connected from this side in the same order I put them here. So The first pin, the interrupt, is not used. This CS pin have been connected to pin 10. The ground is connected to ground. And the last pin is connected to 3.3 volts. You can use it to 5 volts as well. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. Now let's install the library. Click on Sketch, Include Library, Manage Libraries. Wait for this to complete until you can type, and here type BMP3XX. And here you got Adafruit BMP3XX, and click on Install. DF Robot also has a library. We're going to install that as well. So the installation is complete. Close this. Now we can open one of the examples. Go to File, Examples, and scroll down. Adafruit BMP3X. And here it says Simple Test. Let's open it. Now let me explain the code. After you install the library, this wire is for I2C communication. We do need the SPI because we need to use very little wires. And these are all definition for SPI. If you want to use these pins, connect them like that, you can leave that. But I'm not going to use it because these are extra. So this is the default hectopascal value for sea level pressure, and here we are defining BMP, whatever name you want. You can put another name here. This is just an object from this instance of the class. Inside the setup, we just set the serial monitor to 115,200. If I click on Tools, Serial Monitor, on this right side you will see that is the number, and this line checks if the serial is not available. Keep it and wait forever and don't do anything. If the serial otherwise, it print this on the screen, and here this one checks if BMP.begin I2C is not true or not available. Then again print this, could not find BMP3, and while one mean the same as this. It means wait forever. So the program will stop at this point. And these are, if you uncomment them, these will be used for two types of hardware SPI and software SPI, which we are not going to use. So that's why they have been commented out. And these are some of the oversampling and filtering initialization that is set by the manufacturer, and it has been implemented here. Do not worry about these. And this is the oversampling is at 8 times. Here set the pressure, that's the temperature, oversampling, pressure, filter coefficient 3, and the frequency is 50 Hz, which means the output data, it will read it 50 times a second. Now this code will run only once. Inside the loop, this says if BMP perform reading. If this can read it, it will be true, otherwise false. So if this is false, then print this and exit. It says failed to perform reading. Otherwise, if this is not true, then we have this text temperature, BMP.temperature. So this is the value that we need, and this will print the letter C at the end. This is one line, print, and the last one is print ln. So this will create another line after this. We have a new line, and then we have pressure. You see, this pressure divided by 100, it converts it to hecto. Otherwise, the pressure is just Pascal. It will not be hectopascal, because hectopascal is readable, so we divide it by 100. So this is another line, and then it says approximate altitude. Here it says BMP, read altitude, sea level pressure in hectopascal is passed to this function of BMP object, and it will print approximate altitude, and it prints M at the end, so it looks like meter. And then we are creating another separate line, wait 2 seconds. So of course you can change it, you don't have to set it to 2 seconds, make it. And this sensor can go up to 5 milliseconds, which will be very fast, but make sure to remove all these serial print values. You cannot print it this fast. So remove these and use the pressure or temperature or whatever you have in your application. Let's say you want to use temperature for something. This is a temperature, I'm copying it, and you want to take some action. Let's say you want to turn on a relay. So here you say F, temperature is greater than 38 degrees. Let's say you want to check the temperature. If it is greater than 38 degrees, open and close. And here you can turn a pen on or do something, turn a device, camera, whatever you want, or send SMS. But for simplicity, let's say you want to turn on pen 10, which is connected to a relay. So digital write, pen 10, high. So pen 10 will be high. Else, digital write, pen 10, low. So this was just a very simple action, but you can have multiple statements, multiple things that you can do. This was just for temperature. You can do the same thing for altitude. You can do the same thing for pressure and take action. If you're my student and following my course, you should already have your system ready for LCD. Otherwise, watch the video because I'm not going to explain it here fully. But quickly, how to install the driver for this, I will provide you the link. Download the file, the library for this LCD. Click on Sketch, include library, add .zip library, and then point it to where you have saved it. If this was the zip file, select and click open, and it will be installed. Explain the code. This is part of the Arduino. You don't need to do anything. The wire is for I2C communication. I'm defining here an integer BMP VN pin. This is the voltage for BMP, and I've defined pin 12. You can change it to another pin that you wish. And this is just Boolean for Fahrenheit. I was trying to do for something. It's just extra. This line is LCD liquid crystal I2C. This is for the LCD, and here we are defining from the same class. We are getting the instance of the class and creating an object called LCD, and we pass here the address for the LCD 0x3f, and then 16 mean 16 line and 2 mean 16 character, sorry, and 2 mean 2 lines. To get this address, you need to I2C scanner. I will provide you here. This is a I2C scanner. I will provide you the code. Download and install it and upload it to your Arduino. When you are uploading this, make sure to disconnect the sensor. This is just for the LCD. If I open it, now you will see that I'm reading 2 addresses. This is for the module, and let me disconnect that. You will see that we are reading only 1 address, 0x. Before it was 2 for both of them. So this is for the LCD. I'm just closing it. I will provide you the link for this. So that is the address that we are reading from that screen. Inside the setup, we are defining the BMP VN pin, the voltage pin, as an output, and in the next line immediately we are getting the same pin and we are setting it to high. So this will generate 5 volts at this pin, which we define here, pin 12. So we don't need to use breadboard or anything. This is just defining the serial monitor to print some text for us. I've explained this before in the previous introduction. I'm not going to explain it. This line is initializing the LCD. This is turning on the backlight. This is just printing the Robojax text on the screen, and this is just printing the text on the screen. You will see that we are reading only one address, 0x. Before it was 2 for both of them. So this is for the LCD. I'm just closing it. I will provide you the link for this. So that is the address that we are reading from that screen. Inside the setup, we are defining the BMP VN pin, the voltage pin, as an output, and in the next line immediately we are getting the same pin and we are setting it to high. So this will generate 5 volts at this pin, which we define here, pin 12. So we don't need to use breadboard or anything. This is just defining the serial monitor to print some text for us. I've explained this before in the previous introduction. I'm not going to explain it. This line is initializing the LCD. This is turning on the backlight. This is just printing the Robojax text on the screen, and this is just printing the text on the screen. Text is the text that you're reading now here, and this is BMP390. That's the text on the second one. This will run only once, and then you will not see it again. Inside the loop, this line is clearing the screen, so every time we read it, we have to clear the screen. And this line, LCD display, is a function at the bottom of the code, which I have written to display. First, we put the character 0. For example, let's wait for this, and then yes, character 0, line 0. This means line 0, and then we put this text. That is the text that you saw as a Celsius. And then we did not worry one space, and then this space is being printed on the screen, and then 99 means we don't worry where this text is happening. I just put that number because we don't have 99. And then line mean at line 0, and here this get BMP. If you want to print Celsius, you just put Celsius, and here we put the unit. So this line, if you want to print it as a Fahrenheit, just wait, you will see it print FAHR Fahrenheit. Because Fahrenheit was long, I just put it as dot, and at character 9 it goes and prints it, and here we just say get BMP F. So if you want Fahrenheit, and this is the unit. After that, after 4 seconds, we clear the screen again, and then we print the pressure, PRES, and then actual pressure reading. Here we say get BMP P, and this line is printing the approximate altitude, AP alt, approximate altitude. We use A, and then the unit is M, meter. Get BMP, when we pass the character here, this is reading the temperature, and we check if it is Fahrenheit. Then the temperature, we are multiplying it by this value and adding, so it becomes Fahrenheit, and we set it at a value. If somebody asks for Kelvin, we add the temperature we add 273.15 to temperature, that's Kelvin. If somebody wants pressure, we get the pressure divided by 100, so it will become hectopascal. And if it is A altitude, then we get the altitude, else we get the temperature, which is the just regular temperature, and we return the value. So this is getting the value. I'm going to show you how it is displayed. And here that LCD display all those information that we are passing. This sets the character where to start printing the value, because we print the text and then we print the value. This is printing the title that you are passing, whatever it is, Celsius, pressure, whatever. And then we check if it is not 99, which means set the cursor to somewhere. Otherwise we don't set it, and then we print the value, whatever is this value, either temperature, pressure, altitude. And after that we print the symbol. If it is C, we say print this degrees Celsius. This round is printed using character 233, and then we print C. And then if it is Fahrenheit, we print F or Pascal, all these units are printed using these values here, hectopascal, meter, print M, and that's it. So this was the full explanation of the code. And here is the code for using it with 2004. Everything is the same, except you have to type here 20 for number of characters and 4. And of course you have to put the I2C or I2C address using the I2C scanner. And here's the code if you want to use the SPI communication. These pins have been used here, pin 13. In order 10, 11, 12, 13, these are from right to left on the module. Exactly the same from here. So that goes to 10, 11, 12, 13 in the same order that you see them in here. And here inside the setup, I used this line that uses all those pin definition and passes them to library. The rest of the code is exactly the same. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. So here is a sensor. Let me open the serial monitor, and here this is now showing the value like that. And it shows 23.9 degrees Celsius, the pressure, and that's approximate altitude based on the pressure, 127.56. Now I have this heat gun. Let me apply some heat. I have to be careful not to burn it because this has a limit up to 90 degrees Celsius. So I just stopped it now. Still it's sensing 56, 59 degrees Celsius, 61 and 64 even still. Now I think it should go backward slowly because it's stopped now. Yes, so now it's going down. If I put my finger and cool it down, it might go faster. So and here is the demonstration with BMP390 on LCD. It shows the degrees Celsius and degree Fahrenheit, then the pressure in hectopascal and also approximate altitude. So it's just rotating. I'm just providing this demonstration for learning purpose, so you might not need everything. I've explained the code fully, so you can remove any element that you want out of this. Applying some extra heat with the heat gun, so you will be able to read it. And here, I hope it doesn't burn my hand. So now let me apply more heat. I applied a lot of heat, so let's wait. 52 degrees and 69, and that's in Fahrenheit, 126. So the sensor is just printing whatever speed you want. So that's the pressure. And just let's wait. Altitude 105 meter at the moment based on that pressure. And here is a demonstration using the 2004 with 20 characters and 4 lines, where you can see everything on the same page. Temperature in Celsius, temperature in Fahrenheit, the pressure in hectopascal, and approximate altitude. all in one with the same sensor. Let me demonstrate it. I've set the start temperature to 30 and stop at 45, so I can test it and you will see the result quickly. But for real life application, this will be like whatever you want, very close, like 2-3 degrees difference in between. But it is just a demonstration right now, and I will apply this heat gun. You will read the temperature here. At the moment it is 22 degrees Celsius of this sensor, and I'm applying some heat using this heat gun. So you will read it in here. When it reaches at 45, it will turn off. As you can see, it says relay off and the light is off. It's now almost 54. Now this light is off, which means the relay is off, which means the heater is now off because the temperature is very high. When the room gets cooler back to 30, it doesn't allow it to go below 30, so the heater will turn on. So this will be connected to heater via these terminals in here. So the relay will keep your heater on until it reaches back to 45. So right now it's 50, 52 degrees. Let me cool it down by putting my finger maybe. So if it gets cooler, yeah, 46. Now this will turn on. As you can see, it turned on at 30. So the heater is now working to heat up, and then when it reaches back to the stop level, it will just stop it. And here for elevation test, I'm gonna go to this spot in Ajax, Ontario. This is the spot. I'm going to go to this building on the 25th floor. First, we have to test the altitude at this spot. This is the ice skating field. I'm sitting in here. And here, this is the project. And we are reading minus 10 degrees Celsius, 13 degrees Fahrenheit. And strangely enough, I'm getting minus 15. We are in this area. So I'm going to go at the 25th floor there and then measure. At this point, when I measure the temperature and altitude, I'm going here at the 25th floor, and here on Google Earth, it shows the elevation at this spot is 85 meters. Also on the right corner here, you can see the elevation. And now I'm going to the 25th floor. Look.
25th floor.
Let's go. And here, this is where I was at the bottom. Now here I'm on the 25th floor, and here we are. And we're reading 57.2 meter, and on the first floor it was showing minus 14. So minus 14 plus this number, minus 15 plus this, it makes sense. So that is approximate altitude, and the temperature shows 18. I just opened the window, but the room is around 22, 23 degrees. This is just close to the window. I'm here at the 25th floor, and here is the project. Minus 10 degrees Celsius, minus 9.89. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.